here.
Professor, I had a question.
Go ahead.
So the bookstore hasn't sent me the code for me to access the Pearson. So I was wondering, would I still be able to complete the assignments once they actually send me the access code?
Okay, yeah. Are you getting your access code from the bookstore?
Yes, I already purchased the books, but they just haven't actually sent me the code yet.
Did you buy like a hard copy book,
No,
brand
I
new?
bought it online
Morehouse online? I mean, through the bookstore?
to the bookstore. Yes, sir.
Because it should be instantaneous. Like it should be instant. Like that's not something you should have to wait for.
Really?
Nah, sometimes you do have to wait. I had to wait for mine.
But
Yeah,
it's an access code.
yeah, yeah. It's an access code.
I went up there earlier today and they had just actually put
Oh,
in the order.
so the other thing, right? So yeah, I was like, I know there's some solutions. This usually happens every semester. I just can't remember what it was. But so when you log into Pearson, at some point you should be prompted for like payment. There should be a page that come up says enter an access code or purchase or whatever.
Mhm.
At the bottom of that screen, you're going to see a link that says get 14 days of temporary access. That'll give you 2 weeks full access to everything. So as long as you know you're within 2 weeks of getting the access code, that way you don't fall behind. And even if you like, it's like 2.5 weeks or whatever work you're working on, it'll save it for you.
Okay, thank you.
That was a good question. All right, and that actually is a great segue into the start of class. So, welcome, gentlemen. I hope everyone had a great weekend. And so we're meeting today and Wednesday. I think last time we met, I encouraged you, like it was a good idea to do your best to try to get through 1.8 by today. So our intent today, our goal is we're going to work on 1.5 and 1.6 today together as best we can. We only have a little over an hour. So that's about 25 minutes per section, right? So I'll probably go ahead and start a timer. Hey, Google, start a timer for 25 minutes.
All right, 25 minutes. Starting now.
So yeah, that gives us, 25, like half the lecture for 1.5. We'll do is the best we can with that time, and then the remaining for 1.6. And it'll have this rhythm, I think, through the end of chapter 2. Right? Yeah. Yeah, and if you have questions, just feel free to unmute yourself to get my attention or type in the chat. Either type in the chat or the Q&A. Hopefully everyone is making their way through the assignments. Just as a reminder, as a friendly reminder, the structure of this course, it is designed for learning to be done on your own. There's a live component, right? So we do meet twice a week, Monday and Wednesdays. What is this? From 6 to 7:15 right here on Zoom. And obviously we don't have that much time together to go into a lot of details. So that's why I created my pre-recorded lectures on my YouTube channel, Beautiful Mind Phifer. Be sure to like, share, and subscribe, and make sure all of your notifications turn on, at least while you're my students. It's a shameless plug. It costs you nothing. And then, once you get out of here, then, you can keep the subscription to suppress the notifications. But it's important to be subscribed, at least while you're one of my current students, because when students start using the Ask My Instructor in Pearson and started asking for support with the homework, that's where I'm going to post my reply. So when students start using the Ask My Instructor, I'll take it, load the screenshot, do a video response, load it to my YouTube. And then that way, if you're subscribed, you'll see, oh, he posted this or whatever. The main thing is just you want to be aware of what I'm posting. And then, yeah, somebody have a question once? Let me see what else. So yeah, the main thing is the access to Pearson, full access to Pearson. And we have a pretty aggressive pace to start. Once we get past chapter 2, then it kind of dials back to 1 section a day instead of 2 a day. And it's really easy to get behind. So, but again, everything is there. Also with our assignments, we get unlimited attempts on everything. The system is set to take your highest score. And there should only be like a 5% late penalty. If it's not 5%, let me know. And I'll try to catch as many of those as I can. Once students start doing the assignments, I can't change it. So, the earlier somebody can alert me, then the more time I have to change it, if possible. Let me see what else. I think that's the meat and potatoes. Again, if you have questions, feel free to unmute yourself or type in the chat. I am monitoring the chat. I hope everyone had a good weekend. So let's go ahead and get the party started and kind of get into this material. So let me see. Let's do off the dome a recap from last week. Man, okay. I gotta disable it. That's annoying.
Great. Professor, I have one question.
Yes.
So I saw that there was multiple due dates for today at 6 for stuff that we haven't learned already. Like even the quiz was due at 6 today. So I was wondering if if those due dates applied.
What sections?
It was all of 1 and the second week and the first quiz.
Okay, let me check that. Hang on. Give me a moment. Let's see. Low power. My device is lagging. Okay. I don't think I remember this. Yeah, part of it is Apple has been like intentionally slowing my device after the update. They, the older devices, they trying to force you to get newer devices. So now my device doesn't have iCloud, so I can't log in as quick. Let's go here. Matter of fact, I think I'll just check it here. Sign in. Let's go. Let's go. Allow. Today is the 27th. That sounds right because we had all of last week. Let's see. So when I look at it right now, when I log in, assignments that were due today, 1.3 and 1.4, we're starting 1.5 today. And 1.5 is due next week. So I think we're on track. Yeah. So that was one of the first things I said when we started class. Like, that's why I encourage everybody to try to get through section 1.8. You know, you want to have completed those assignments by today, but it's okay. Again, unlimited attempts, automatic extension. So I think 1.4 was due today. We're starting 1.5 through 1.8 this week. These assignments are going to do at the start of class next week. So when I checked it just now, it looked accurate. Okay. So I'll just say check it again, and if it still looks out of order or it doesn't look right, then let me know. But again, we're starting section 1.5 today, and so it should 1.5 through 1.8 should be due at the start of class next week. All right, that's why I was trying to get you guys ahead because it's easy to kind of get behind in this stuff. Okay, but yeah, so yeah, okay.
Professor?
Anyway, yes,
Professor, I didn't have a problem turning in any assignments. I just had a question. Did the quizzes stay open past the deadline, or did those close along with other assignments that were due this week?
They should lock out. I mean, they're due. You know, it's like every week, but there should be an automatic extension built into it, so you should be able to access it past the due date and with like a 5% late penalty.
Yeah, it just all right. Bet. Appreciate it.
Yeah. Let's try this again. Share my screen.
Professor, for me, it's a 10% late penalty. I didn't do the last one that was due.
Okay, so that means that it's 10% across the board then, and I haven't changed it. So we're gonna have to go with that because again, I can't change it once it started. Give me just a moment. Share my screen. Start the broadcast. Okay. All right. We're gonna go with it for now. For right now, if you have questions, put it in the Q&A, and I'll pick different times because it's kind of we don't have a lot of time. So again, whatever we don't do together, like our goal for today is what 1.5 and 1.6. Whatever we don't do together, I expect you to use my pre-recorded lectures to finish out to fill in whatever we don't do together. Because on Wednesday we're going to be starting 1.7, whether we do it live or not. But so you have to use my recordings. For right now, if you have a question, just put it in the Q&A, and we'll make sure it gets addressed before we leave. Okay, so last time I know. Okay, so we introduced the limit definition of the derivative, right? So again, pretty much all of calculus is kind of centered around derivative. Essentially, what we're talking about, you know, going forward with derivative and doing the reverse of derivative, right? And so the derivative is just the instantaneous rate of change or the slope of the tangent line at a point, right? So if you have a curve and you consider some point on that curve, and then if we want to consider a tangent line. Now, if we try to draw it manually, we can't draw that tangent line because there's a little bit of wiggle room, so we can't get it exact. So we use the limit definition. As the second point gets infinitesimally closer to that first point, then we get a better and better approximation of the slope of the tangent line at a point, right? So again, derivative is just the slope of a tangent line at a point, and we introduce the derivative with the limit definition like we did last time, right? So now, that was a little bit verbose. Derivative gets easier, but the main takeaway that I want you to get from concept of derivative is that it's the slope of the tangent line at a point, okay? Slope of the tangent line at a point. If you can get that, that'll cover a lot of the other concepts that come down the line, right? Okay, so here we have section 1.5, Leibniz, I always forget how to say that. Notation, I think it's Leibniz notation. And the power and sum difference rules. Let's just take a look at it. So a few objectives here. One, differentiate using the power rule or the sum difference rule. Two, differentiate a constant or a constant times a function. And three, determine points at which a tangent line has a specified slope. So I think what we're doing is getting into the shortcuts. Like instead of doing the limit definition of the difference quotient for the derivative, we can bypass all of that and just look at the question and write the answer. Right. So this is like my favorite part. Like it drastically simplifies that process that we were doing last time. So buckle up, Buttercup. Hope you're ready. Right. So Leibniz notation, when y is a function of x, we will also designate the derivative f prime as dy by dx, right? So the Leibniz notation is this dy by dx. What that stands for is the derivative of y with respect to x, right? So that dy by dx, that just means the derivative of y with respect to x. So yeah, we'll dive deeper into that momentarily. Again, this is read as the derivative of y with respect to x. So that dy by dx, that's our Leibniz notation. So, okay, so this is our first shortcut. Now, this looks a little bit daunting, but after you do it about 3 times, you'll see how it's like instantaneous, right? So when we did the power rule last time, you know, we had to do things like the limit, let me see, the limit is h tends to 0 of the difference quotient. Then if it was like squared, we had to like FOIL and do all these calculations. That whole page of the limit as h tends to 0, the difference quotient for the derivative, with this, you just look at it and get the answer. So the first technique that we have here is called the power rule. And so when you basically what it's saying is that when we take the derivative of a power, the derivative is going to be you bring the power down and just subtract 1 from the power. So instead of doing that whole page of calculations, again, the derivative of a power, you just bring the power down and subtract 1 from the power. All right, so that's general. We'll see a few applications. You have a question? Going once, going twice? I think we're good. Participants. Wait, make sure my video is still showing. Here. Okay, looks good. Okay. Yeah. Okay, so let's give these a go. Just to see. I low-key wanted to showcase, I low-key want to do it the way we did last time, but in the interest of time, I'm not going to do it the way we did it last time, just because it eats up a lot of time, a lot of our precious time. So let's demo the shortcut, right? Differentiate. So for part A, right? If we have y equals x to the power of 5, and we want the derivative of y, we have about 3 different ways that we write the notation for derivative. Sometimes you'll see me write y prime. Sometimes you'll see me write dy by dx, and sometimes you'll see me write f prime of x. These all mean the same thing, right? So I'll just put it here like this. So the derivative, sometimes I write it like this, sometimes I write it like this, and sometimes I write it like this. These all mean the same thing. Let me clean up the last one a bit. And again, if anything isn't clear, for right now, put your questions in the Q&A. Let me check the chat since I'm here. Q&A looks good. Chat looks good, right? Just trying to keep a flow. Okay, so again, these all mean the derivative. So for the first one, if I want the derivative, I'm going to write it as dy by dx. The power comes down. So the 5 is going to come in front. We subtract 1 from the power. So then the derivative is going to be 5x to the power of 4. That's it. So that's our first little shortcut or theorem or whatever. Right? So the power rule, again, when we take the derivative of a power, it just comes down and we subtract 1. Let's do another one. So for part B, if we want the derivative, so dy by dx, what's the power? We have, so if there's no number written on the variable, what's the implied power, right? And if we do the same procedure, yeah, I think I heard it. I heard a 1. So that 1 is going to come down and we're going to subtract 1. Again, there's an implied 1 there, okay? So then if we do the same thing, the 1 comes down, x to the power of 0, right? The 1 came down, x to the power of 0. What's x to the power of 0? I think that's 1, right? So then this guy is just 1. Hopefully that makes sense. Duplicate. My dog is like losing her mind in the other room, chasing her tail. I know she's bored. I be gaming like, man. Don't get me started.
Professor, I do have a question. I'm sorry.
You good? You good?
So do we have to put like in Pearson, will we have to put 0 or will we just leave it as X?
You talking about for part B?
Yeah.
So the final result is this guy in green.
Okay. Gotcha.
Yeah. I just did the x to the power of 0 for instructional purposes so that when people look at it later, they can see that we're essentially doing the same thing, and then you have to adjust the notation. Okay, let's look at C. So if we do the same thing, power comes down and we subtract 1, right? So then our derivative, dy by dx. So the 4 comes down, so we're going to have a negative 4x. Let me kind of be consistent with my colors. So negative 4 times x. Now negative 4 minus 1 is what? Negative 5. Okay. So now this one, you might leave it like, generally we don't leave it with a negative exponent. It's not gonna mark it wrong if you put all your powers to a positive power. Sometimes they accept negative powers, sometimes they don't. If that ever happens on like an exam, either you can redo it or you can challenge your questions. Like if you just don't, because the exams are a little bit different, right? It's like 20 odd questions. You don't see your score until the end. So, if you want to challenge, you can challenge it, because sometimes the answers that you guys put are correct and it still marks it wrong because of like syntax, or sometimes you guys put it in the wrong form. You're not like following specific instructions. So, if you can challenge it or just redo it. So I'm going to rewrite this with a positive power like this. So I want to say that either of both of these are correct, the above line and this line, but it's not going to mark you wrong for having a positive power. We're going to see how they want it. So let's see how the text submitted these.
Professor?
Hang tight. 5x to the 4. Okay, so for part C, they did leave it as a negative power. So either one is correct, either the way I have it written or with the negative power in part C. Go ahead.
I apologize for interrupting. I was just wondering, did you already take roll? I had gotten here like 10 minutes late.
You're good. So attendance is taken automatically through Zoom, and I check attendance once we get out.
Okay. All right. Thank you.
Yeah. So it basically logs when you guys come and go and everything. So that way I had to like be as efficient and seamless as possible, because again, we don't have a lot of time together. We're almost out of time for this first section. So anyway. So yeah, I did finally figure out how to take attendance automatically. Okay, so that one was good. Let's look. Okay, so here's another one with the power rule. So there's more practice on the power rule. Let's turn up the speed a little bit. So then for part A, so now we have y equals the square root of x, and we want to take the derivative, right? We want to find the derivative. So if we want to do the power rule, can anybody, like in the next 10 seconds, square root of x, how can we apply the power rule to this guy? But what kind of manipulation can we do so that we can do the same thing that we did in the previous? I'll give you like, until my second hand gets like about 15 seconds, give or take. How can we manipulate the first one so that we can use the power rule? 10 seconds. Anybody? Oh, okay. You guys know this. Okay, so square root of x is the same as what? This is the same as x to the power of a half, 1/2, right? So square root is the same as x to the power of half. If it were cube root, that's the same as x to the power of a third, right? Fourth root, x to the power of a fourth, so on and so on, right? So now from here, we can do the same thing that we just did. When we go to take the derivative, the power comes down and we subtract 1, okay? So now in the previous example, they allow a negative power exponent in the end, so I'm going to leave the power negative here when I finish. So if I bring the power down, I have 1/2, and then a half minus 1 is a negative 1/2. I'm going to leave it as, actually, you know what? I'm just going to see how they do it. Okay, yeah. So they didn't. So again, that's why I told you, it's kind of a little bit topsy-turvy. Again, generally speaking, you can't go wrong with leaving the power, a positive power. So like, for instance, with this guy, a negative a negative power, it goes to the denominator, and that's a y prime. So then that's going to be 1/2 times x to the 1/2. But then, did they leave it like this? Okay. And then x to the 1/2 is square root. So because they started with square root, I think we should finish with square root. That's another thing that happens often as well. You kind of want to match the form of how they start. That happens as well too. Okay. So then this is going to be the same as 1/2 times the square root of x. Okay, let's try the next one. See what happens with the next one. Okay. So then for B, if we're taking a derivative, so the power comes down and we subtract 1. So then our dy by dx, okay, 0.7 times x to the negative 0.3. I think I'm going to leave the negative power. Yeah, I think that should be fine. And again, like with the homework and quizzes and things, they're usually specific. Like they'll say, okay, put your final answer using radicals as needed, or they'll say like, be sure to use positive exponents. They're pretty specific for the Pearson, so that to minimize any confusion, just kind of follow the instructions. But the instructions are very subtle, and students often miss like those small instructions. Okay, not too bad. We got those. We're just about out of time. Okay, listen, I think we got another shortcut here. Okay, so we've seen a few examples on the power rule. It says the derivative of a constant, right? So the derivative of a constant is going to be 0. And I'm going to add this. So consider like our y was equal to some constant times x, right? No, sorry. Y was equal to some constant. Now, we could rewrite this guy. If y equals some number, right? This is the same as that number times x to the power 0. So then when we go to apply the power rule, the 0 comes down. No, wait a minute. Sorry. Yeah, we're good. The 0 comes down and we subtract 1, right? So then when the 0 comes down, that's where this result comes from, right? So for that reason, that's why the derivative of a constant is 0. Again, quick recap. When y equals some constant, that's the same as that constant times x to the 0. Then when we apply the power rule, that 0 on the variable comes down and the whole thing flattens out to 0. Now, remember, we said the derivative is the slope of the tangent line, right? If we have a flat constant, if our function is a flat horizontal line, no matter what point you choose on that flat horizontal line, the slope of all the tangent lines are going to be 0, right? Because, it's a flat horizontal line. Okay, anyway. Okay, so I think that's good. Long story short here, the derivative of a constant is 0. So whenever we take the derivative of a constant, it's 0. The derivative of the power function, the power comes down and you subtract 1 from the power. Okay. The derivative of a constant times a function is going to be the constant times the derivative of the function, right? So it's almost like we're distributing that d by dx into the parentheses. We're not officially doing that, but it's essentially what we're doing. I think last time we had some properties with the limit definition. When we had a constant times a function, one of the properties allowed us to rewrite it as, the derivative of the constant times the derivative of the function. And, wait a minute. That should be 0. Something's off here. Oh, okay. No, we're not passing it through. There's actually another property we need to apply. So for right now, there's something else why it works, but there's a property that we need to introduce. So for right now, when we say the derivative of a constant times a function, it's just a constant times a function. What we're missing is when we take the derivative of a product, we got to apply the product rule, which we haven't talked about yet. So I can't go into those details and explaining why this is just yet until we get to that part. So for right now, the derivative of a constant times a function is the constant times the derivative of the function. Okay, so we'll see this in action, right? Okay, here it is. So like for instance, in this part A, it's applying that first property we talked about today along with the one we just did a moment ago. So I think just a moment ago, we said the derivative of a constant times a function. That's going to be the constant times the derivative. So d by dx of x to the power of 4, right? So it's essentially, hey, Google, stop. So essentially, like we factored out that 7. That's not officially what we're doing, but you can visualize it that way and it'll be okay. So now when we're going to take the derivative of x to the power of 4, we're back at what we did earlier, right? So then this is going to be 7 times 4 times x to the power of 3, 28 x to the power of 3. That should be it. Yeah, that looks right. And again, it's just a little bit, like this for instructional purposes, me going into these details. Once you work these like about 3 times or so, then it just becomes second nature. Like you don't even think about all the other stuff. It's just, it just becomes second nature. So then for part B, again, the derivative of a constant times a function is going to be the constant times the derivative. So times d by dx of x. The derivative of x is just 1. So that's just going to be -9. And again, you can kind of visualize this as like factoring out the 9, and now we're going to have the -9 times the derivative of x. For part C, I'm going to rewrite that before I attempt it. So I want to take the derivative with respect to x. Now, instead of working with this fraction, I'm going to rewrite it. Let me see, 1 over 5 times x to the power of -2. So I want to take the derivative of this guy. So now we have the derivative of a constant times a function. Now it's a repeat. So we can essentially factor out that constant times the derivative of the function, right? So now the derivative of x squared, the negative, or x to the -2, the -2 comes down and we subtract 1, right? Okay. So then it looks like we're going to finish with -2 over 5 times x to the -3. And because we started with a fraction, I'm just going to finish with the fraction. So I'm going to say the denominator looks like it's a 5. Space here. The denominator looks like it's what, 5x cubed. The numerator, -2. Okay, we do need to kind of go into the next section. I'm going to scan 28x cubed. If we got -9 there and -2 over x cubed. Okay, that's fine. So notice here. So I'm glad they did this. See, they said that you can leave it with the negative power or write it this way. We chose to write it the second way. That's what I was saying before. Like, honestly, they're both correct. So you can challenge it as long as what you have is correct. I'll give you credit. Okay. All right. So quick check. I usually leave as an exercise for you all. Okay. Let me mention this real quick. So the derivative of a sum is the sum of the derivatives, right? So the first one, again, the derivative of a sum is going to be the same as the sum of the derivatives. Okay. The derivative of a difference is the same as the difference of the derivatives. Okay. I'm gonna have to leave this as an exercise, and we're gonna work questions like this. I'm just not gonna work these specifically. If you want to see these worked out, I'm gonna have to use my recording just because we're out of time. And you also have it worked out here. Also, you can pull a copy of these notes at the end of class. Like if you go into Blackboard, open up our main folder. I think the second or third link says box link daily lecture notes. I load a copy of these notes that we do together in that link in Blackboard. Okay. Let me see. Find the points on the graph at which the tangent line is horizontal. So this is a good one. I really want to talk about this one, but we're out of time. I'll just give a brief overview. We want the slope of the tangent line to be horizontal. That means the slope is going to be 0. All right, it's going to have the slope of the tangent line is going to have a slope of 0. So that's, in other words, it's asking us, when is this derivative equal to 0? So we would take the derivative set it equal to 0, and then solve for x. Again, I'm going to leave this as an exercise. You can find this worked out like an animation and explanation on my YouTube channel, okay, for this lecture. But I'm going to have to leave this as an exercise for you for right now. Slope of 6, right? So this one wants us to find the points on the graph where the slope of the tangent line has a slope of 6. So just like the previous one, you take the derivative, but instead of setting it equal to 0, in this case, you would set the derivative equal to 6 and then solve for x. And then, again, if you want to see those details, you have to use my recording just because we do need to go to the next section. And we are going to work things that are similar to this. There's nothing really that special going on here. Okay. So not too bad for section 1.5. We went over essentially one main shortcut with a few subsets or spin-offs of it. It was mainly the power rule, right? Where the derivative of a power, the power comes down, you subtract 1, and then we just explore different ways that it'll show up. Like if we had a constant times a power, how that we worked an example there. If we had the derivative of a sum, that one was a sum of derivatives, so on and so on. So this one was mainly centered around the power rule, right? So, okay, I'll make a copy of this available at the end of class. Let's go ahead and hop into section 1.6. All right, single page. Let me check the chat real quick. I know it's a little bit intense, but I feel like it's not as bad as it seems, but okay. So section 1.6. So again, we're going to do the best we can with this section. And then on Wednesday, our goal for Wednesday, we're going to work on sections 1.7 and 1.8. These assignments are due next Monday at the start of class. And basically every Monday at the start of class, the previous week's assignments are due. It seems like there's a 10% late penalty. I may go through and try to change as many of them as I can to 5%, just because, it just depends on if I can get through it in time. Okay, so 1.6, the product rule and quotient rule. So in one of the little explanations we had in the previous section where we took the derivative of a constant times a function, and I paused and I was like, well, there's something else we need to talk about. This is what we actually need to talk about is the product rule. Because we have to use the product rule in order for that to work. And so we'll go ahead and do it here. And if I remember, we can revisit that and I can show you using the product rule how we develop that shortcut. So a few objectives here. 1, differentiate using the product and quotient rules. 2, use the quotient rule to differentiate the average cost, revenue, and profit functions. Okay. So product rule and quotient rule. So first we're going to take a look at the product rule. So let f of x be the product of two functions, f times g, then f prime of x. So whenever we take the derivative of a product, right? That's what that second line is saying right here. So if we take the derivative of a product, the way I remember the product rule, I usually go first times the derivative of the second plus second times the derivative first, right? So that's how I do it. Again, first times the derivative or d by dx of the second plus the second times the derivative of the first, right? So that's pretty much the product rule. First times the derivative of the second plus the second times the derivative of the first. And so that was the property that we needed. Let me kind of revisit real quick. So I think we were looking at d by dx of a constant times a function. Okay. So then if we apply the product rule, first times the derivative of the second plus second times the derivative of the first. So first is this guy. The derivative of the second, I'm going to write it as f prime. First times the second plus second. The derivative of the first, the derivative of a constant is 0. Right? So I think that's something we said, right? Right. So because that guy is 0, this expression is gone, and so that's where that came from the previous, right? So I think when we said the derivative of a constant, I think we mentioned it as like it's almost like we're factoring out the c. Well, what you see here in green is why we get that result, because of the product rule for differentiation. Okay. So the meat and potatoes is in purple, and then a reference is in green and blue. Okay. All right. So let's look at an example of the product rule. I'm going to write the product rule. So let me see. If I say d by dx of f, I'm going to just abbreviate it as f times g. That's going to be the first times the derivative of the second plus the second times the derivative of the first. Oh, sorry. Okay. So first times the derivative of the second plus the second times the derivative of the first. Okay. That's the product rule. All right. So the first is this guy. I'm just copying it. So now before I take the derivative, I'm going to write it as d by dx. So I know I'm taking the derivative of that guy. So I'm taking the derivative of the second, which is this. That's the first half. Now we're going to say plus the second, which is this, times the derivative of the first. Kind of out of space. Kind of got it to fit. Okay. First times the derivative of the second plus the second times the derivative of the first. Let me see the time. Okay. So now we're going to go and do our calculations. So the first is just going to come down. Again, just copy it. Okay. So now the derivative of the second. I'll do this guy in blue just for it to pop a little bit. Actually, let's choose a different color. We'll do this green color. No. I'm trying to use a unique color. We'll do purple. Okay, finally chose one. Because my different colors, I usually have different meanings. Like, I like to keep formulas in green. Things that, like, it's my own personal flair that I'm sharing. I usually like to do those in purple. So that's why I kept moving. And I didn't want to do blue because blue are like my edits, like my things that I don't always write, but I want you to be aware of. So that's why I kept changing my colors. Okay, anyway. So now, if we do the derivative of the green guy, right? So that first term, again, terms are things we add and subtract. Factors are things that we multiply and divide. So the first term, that 3x squared, if we apply the power rule, the 2 comes down and we subtract 1. I'll note it like this, right? Like we did before. So then we're going to have 6 times x. I think that's all that's left there. Oh, wait, that's not it. That's just the first term, right? And then the derivative of the second term, negative 5x, that derivative, if you do the same thing, power comes down and you subtract 1, right? That's just going to be negative 5. Okay. So the derivative of the orange guy looks like it's 6x minus 5, right? So again, last week when we did derivative, we had the whole limit as h tends to 0, the difference quotient. Now we've explored some shortcuts. So instead of having to write out a whole page of that, you can just look at it and do it in an instant. Okay. Now that's the first part. The second part, we got this 3x squared minus 5x. And again, with these like presentations, don't try to follow every little detail that I do, because it'll kind of bore a hole in your head. Like it kind of drives you a little bit crazy, to be honest. The recommendation, just try to get the gist of what we're talking about, and then you really don't see it until you attempt these on your own. Like if you're trying to follow my work, it's difficult to follow somebody else's work, because you kind of got to go at your own rhythm, and each step needs to make sense. Like when we're in class like this, just try to get the gist of what we're doing, and it really doesn't sink in until you go on your own and try these yourselves, right? So as long as you get the gist of first times the derivative of the second plus the second times the derivative of the first, I'm doing the details right now. Just get the gist, and then when you go and you're practicing on your own, when you're reviewing your notes or working on the homework, that's when it's really going to sink in. Don't try to read too much into it like right now. Also, this is why I encourage to try to get ahead, because if you already knew this was coming, it's a much more amicable experience if this is a review versus this being your first time seeing this. Then you're like, you get intimidated, or the students get intimidated, then they're like, they just shut down. Versus if you kind of get ahead, and then when we're live as a review, that's a much better experience for the students. But I can't make you get ahead. I can only suggest it. I can only show you the door. I can only show you the blue pill or the red pill. It's up to you to decide which pill you're going to take between procrastination or, you know, preemptiveness. Or if I can only show you the door, you have to decide if you're going to open it and try to get ahead, or procrastinate and be in that route, right? So just a little bit of tips on how to manage this stuff. But let me go ahead and finish this out. So the derivative of the second guy, I guess I'll do that one in brown. I'll do burgundy. Okay, what was that? X to the 4. So that becomes 4x cubed. Negative 2x to the 3 comes down. Negative 6x squared. Okay. And the derivative of a constant is 0. Right. Again, what we did here, the power came down, we subtracted 1. Power came down and we subtracted 1. And the derivative, it's essentially power comes down, you subtract 1. But again, we said the derivative of a constant is 0 for that last term. Okay. So is there anything we can factor? 6x squared. We might leave it like this. This might be it for this one. Yeah. Yeah, cool. Sometimes you can factor and simplify and take a little bit further, and sometimes you can't. So that's another challenge. Like, okay, we did the product rule, and then this is kind of like verbose or wordy. But again, we just did the product rule, then that was it. We left it. Right? We didn't do any more. Okay, so that's fine. All right. That was an adventure. We got a solid 30 minutes. Quick checks I leave as an exercise for you. Let me check the Q&A. Q&A in the chat look good. I don't see any hands or anything. Okay. So again, I feel like it might be like a little bit intimidating, but I want to encourage you. Is like, it's not as bad as it seems. It's only like that because this might be your first time seeing it. Once you look at it for a little bit, you'll see it's not as bad as it seems. Right. So, and again, if you can, do your best to try to get ahead. That way, these will be reviews. You can use my YouTube recordings. You don't have to wait for us to be live. You can watch those like the weekend before, and then that way we'll be reviewing here. Okay, quick checks I'll leave as an exercise for you. Let's talk about the quotient rule. Let's talk about the quotient rule. Let's see what to do. Okay, anyway. So the quotient rule, right? So with the product rule, we said what? The first times the derivative of the second plus the second times the derivative of the first. The way I remember the quotient rule is I go low D high minus high D low over low low. Let me write it out. All right. I know that's weird, but that's how I remember, right? So again, the quotient rule, the way I remember it is low D high minus high D low over low low. Right? So again, that's how I remember the quotient. Low D high minus high D low over low. And so in other words, what that means is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom square. Okay, let me say that one more time. The way I do quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom square. Okay, or high D low minus, low D high minus high D low over low. Okay, whichever you resonate with and you can get to sink in. So as you kind of make your way through this little journey of business calculus, hopefully you're like, organization is key. It takes time, which is like a lost art in this day and age, which you got to like slow things down. You got to remove distractions. But in this age of like AI, internet culture, patience is lost, right? It's an art form in this day and age. Like, no, people don't have patience. Most people like stand in front of the microwave, like, will you please hurry up? It's a microwave, right? You didn't have to like go build a fire from scratch, right? So I say that because this thing of mathematics is not for everybody. You have to like slow things down, remove distractions. Like I do the best with this kind of stuff. Like when I first wake up, I'm usually up like 2-3 in the morning every day. Just that's when I wake up. I stop fighting it. I just go with my natural rhythm. And so when I was a student at Morehouse, that's when I did all my study. Like I was in the Morehouse suites and I went into a little study room. I loved it. It'd be 2 and 3 in the morning. It was a ghost town. No, everybody was asleep. So it was extra quiet, minimal to no distractions. I might get myself some snacks, some water, drink and stuff like that, go to a little study room. And I'd be there for hours, and just taking it one step at a time. That's how I learned all this stuff. And then also it was like I did work study. I worked in like Archer Hall. And so our work study, they paid me to sit at this desk for hours on end. I was like, in my mind, I was like, well, hell, they're gonna pay me to sit at this desk and check IDs as people come and go. I was like, if I'm gonna be sitting at a desk for hours on end, I might as well just go ahead and do my homework. And so sitting at this desk, again, taking charge of time, manipulating time, I was multitasking, getting paid to do my homework twice because I was there on scholarship and work study. So it was crazy. I was like, man, that's what I made the most money when I was a student. Now I was an adult. I'm like, man, it's so difficult, to get money. But I was like, it's okay. I always find a way. But again, I say this to say, you got to like slow things down and like remove distractions. So that, be sure you're rested, got, snacks or whatever it is you need, bathroom and facilities. Okay. All right. So let's give it a go. Here we're asked to take the derivative using the quotient rule, right? Low D high minus high D low over low low. Okay. So F prime is the bottom, which is this guy. I think we did this color last time, times the derivative of the top. So D by dx. The top is this x squared minus 3x, right? So that's the bottom times the derivative of the top minus the top times the derivative of the bottom. I will do burgundy. So D by dx. Bottom times the derivative of the top minus the top times the derivative of the bottom, which is this guy, all over the bottom squared, low. Okay. All right. So now let's take our derivative. So we got this x minus 1, that just comes down. The derivative of the top is 2x minus 3 minus top. The derivative of the bottom, the derivative of x is 1. The derivative of a constant is 0. So then that's ultimately just 1, right? So you don't necessarily need to write that one. I'm just doing it for instructional purposes. The bottom squared, I'm going to leave it for right now. X minus 1, I'm going to leave it as x minus 1 squared, okay? Do we have anything that factors? I'm always looking for something to factor out. We could factor out an x, and it'll leave us with x minus 3. So I think since it doesn't look like anything is going to cancel, I'm just going to expand the numerator and simplify it down, okay? So if I FOIL that first part, 2x, let me see if they did that. Yeah, they did it. Let's keep going. So 2x squared minus 3 minus 2 is minus 5x plus 3. So that's the FOIL of the black and the orange. And then we got to distribute a negative here. So if we distribute that negative, we'll get minus x squared plus 3x. And then the denominator stays. Okay. So that's an x squared. Now I'm just combining like terms, right? Minus 5 plus 3 is minus 2. And looks like all that's left is a plus 3. You see, like term here. Like term and like term. You see it here. X with the x, you see it here. And then the 3 is left over. And then the denominator just stays. Okay. So a little bit of an adventure. Again, as long as you can get the gist, it really doesn't sink in until you go home and do this on your own. trying to follow what I'm doing might kind of bore a hole in your head. It might kind of, because that's what it does to me. Like it's always been like that. Like when I was a student, Morehouse or grad school, trying to follow the professor's work, I was just like, it just give me a headache, and I'm like, man. But I was like, okay, I would just release it, and then like, okay, let me just get a gist. I would like do recordings, and all this other kind of stuff. Like I would sneak and do my recordings. Some professors didn't care, and some did. So I would just sneak and just do it. I didn't really care. But I would use the recordings. I still have those recordings now. But this stuff is all recorded. These sessions are recorded. You get a copy of these notes. So it's completely different. I'm just doing the things for you all that I wish my professors had done for me. And some of my professors would do this, but not many. So, but it wasn't until I went on my own, I was reviewing my notes. I was no saint, obviously. I didn't always review my notes, but whenever I did, that's when it was sinking, right? So, but trying to follow what they did, I was like, what? But then I'd go back, and that's when it was sinking. X squared minus 2x plus 3 looks good. We got a solid 20 minutes, so let's keep the party going. And we're almost done. We actually don't have that many slides left. Quick check I usually leave as an exercise for you all. We got some definitions here. So if C of X is the cost of producing X items, then the average cost of producing X items is C of X over X. The cost divided by the number of items. That makes sense, I guess. If R of X is the revenue from the sale of X items, then the average revenue from selling X items is R of X over X. If P of X is the profit from the sale of X items, then the average profit of selling X items is P of X over X, okay? So these average functions is the function divided by X. So then Paulsing's greenhouse finds that the cost in dollars of growing X hundred geraniums is given by this cost function. If the revenue from the sale of X hundred geraniums is given by this revenue function, find each of the following. The average cost function, so that means C of X over X, the average revenue function, which means R of X over X, and the average profit function, which is P of X over X. And also keep in mind that profit is what? Revenue minus cost, okay? When X hundred geraniums are grown and sold, that's part A. And in part B, the rate at which average profit is changing when 300 geraniums are being grown. So it says the rate at which average profit, so we find the average profit, and then if we want the rate of change, basically take the derivative. Yeah, I think that's it. Anyway, I kind of need some space. I think this is the last one. Let me see, can I copy? So I know this is a little intense. We're gonna do the best we can with it. Paste. Nope. Didn't allow. Let's try it again. Copy. Duplicate. I didn't really want to do it this way, but you gotta do what you gotta do. Come on. Okay, right here. All right, let me make sure it's in a proper location. And let me get a copy of this for reference. Okay. All right. All right, so let's see. All right, so first it asks us to find the average cost, average revenue, and average profit. Okay, so they give us our cost function and they give us our revenue function. So if we want the average cost, so let me see. I'll say C of X average is going to be what? C of X over X, right? So then that should just be the 200 plus 100 times the fourth root of X over X, right? We just took that function divided by X, okay? I'm going to highlight it just like this, just so it pops off the screen a little bit. And again, we're working on part A. So that's our average cost function. Then we want our average revenue function. So we want the revenue function, the average. Our revenue function is given, so that's the 120 plus 90 times the square root of x. And then we're going to divide by x, so that's r of x over x, okay? And then they also ask for, they want the average cost, average revenue, and the average profit, okay? Profit function. So then our P of x, average, P of x over x, I think we could just subtract these two results, right? Say the revenue. Well, here, let's do this. Let's do this. So that should be P of x over x, right? P of x is what? The revenue minus cost. So we could say R of x minus C of x over x. Okay, and I'll continue working over here. This will be it. So then our revenue, so that's going to be what? The 120 plus 90 times the square root of x minus the cost function. Notice my use of parentheses. 200 plus 100 times the fourth root of x. A little bit jammed. We're going to do all of that over x. Okay. So then it's going to become what? 120 plus 90 times the square root of x. Distribute this negative, right? That's the purpose of the parentheses. So then that's going to be what? Negative 200 minus 100 times the fourth root of x. Hopefully I'm not making mistakes. Okay. So then combine like terms. It looks like, is that a negative 80? Plus 90 times the square root of x minus 100 times the fourth root of x all over x. Okay. So that's the profit function that we got. Here's our revenue function. Okay. Or average profit. Sorry. And this is profit average. Okay. I think that's it for part A. So those three results are highlighted in blue. And then for part B, it says find the rate at which the average profit is changing. Do they really want us to take the derivative of that? Oh my goodness, that looks nasty. When 300 uraniums are being grown. So it looks like they want the derivative of the average profit when x is 300. Oh, no, I think we need to. Give me a moment, let me think about this. Because if we plug in x, the rate at which the average profit. Yeah, I think they want the derivative when x is 300. But that just looks, I mean, because it would be what? The bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Then you plug in. So it looks like, we got it 15 minutes. All right, I'm going to go ahead and take the derivative. So I'm going to take the derivative. I'm going to get this long, nasty, expression. But I'm not going to simplify it. I'm just going to plug in when x is 300. When 300 geraniums, actually, when x is 3, right? Because this is all in terms of hundreds of geraniums. So I'm just going to take the derivative of this guy and then just plug in x equal to 3. So I'm just going to do the quotient rule quick. I'm not going to simplify it. Then I'm going to take my x and just plug in 3 for x. I think that'll get it. All right, so let me see. So then for B, so P prime of x average, I think this is what they're asking. I'm going to go ahead and do it real quick. So the bottom, the derivative of the top, okay? So that first term derivative is 0, so it's gone. Okay, so the second one is what? 90 times 1/2 x to the minus 1/2. I'm going to just leave it like this for now. Bottom, okay, wait, we're still going. Derivative of the top, okay? Man, that's nasty. So then we got this, what, minus 100. The 1/4 comes down. It's going to be x to the power of a negative 3/4. Okay. That's the bottom times the derivative of the top. then we got to say minus, so I'm out of space, the top, all of this, and it would help if I gave myself some space. Sounds the derivative of the bottom. Fortunately, the derivative of the bottom is just a 1, so we're good there. And then all over the bottom squared, right? So we get this nasty thing. I'm not even going to try to simplify it. I'm going to just try to be neat and organized. Let me do like this so you know that this is all part of the numerator. So then what I'm going to do is take this, and I want to evaluate this when x is 3, right? And if it's wrong, then we have the notes in the next slide. I'm not going to go back. So now we just want to do p prime of 3 average, okay? So we're going to let x be 3. Now, I would probably just use my calculator. If I'm going to try it in my calculator, if I get it wrong, then we'll clean it up. I just went on and attempted since we still got a solid over 10 minutes. So let me open up my calculator. I know that was intense. Close the tab right here. Oh, you're gonna make me load you again? Okay, I agree. Choose the file. It's gonna be here. It's gonna be here. I think it's this one. This one. Okay. And then reload. Okay, refresh. Let's go like this. All right. Oh, seriously? So when I moved away from the app, it started updating, and I get back in for a few more seconds. And hopefully our work is still going to be there. I mean, if it's not, we already have it worked out. So, you know, we'll get to the bottom of it. And I'm just trying this just because, you know, I want you to see that, like, okay, sometimes they do get a little kooky. So you have to, like, again, slow things down. It would be better if I got like a fresh sheet of paper and gave myself space instead of trying to jam it into that little corner or whatever. Okay. Okay, it looks like our work is still there. Okay. So now I'm going to attempt to put this in a calculator. All right. And so what I'm going to do, again, if I don't get it right, then I'm just going to piggyback off of my prepared notes. What I'm going to do is go. Honestly, there's another technique that we can use. We did the derivative manually. This calculator can actually calculate the derivative. I don't remember it off the top of my head. Let me see if I can do it. Hang on. Where is it? P prime P of x, right there. Okay. So, because I feel like, you know, it's a good chance that I made a mistake when I took my derivative. So I'm going to go to the line above it where we have the blue highlight, and that's my P of x average. I'm going to start there, and I'm going to let the calculator do the derivative. I'm going to see if I can pull that up. So I'm going to put the average profit here. And to take it a step further, I'm going to do some calculations here. So my profit function is the revenue minus the cost. So I'm just going to do 120 plus 90 times the square root of x. Okay. Let me see, that's the revenue minus the cost function is 200 plus 100 times x to the power of 1/4. Okay. So that's the, missing the parentheses. Profit function, so I need a parentheses here. Insert like this. Okay. So that's my profit. That's my revenue minus profit. Sorry. Revenue minus the cost. So that's my profit function, right? So if I call, so to call on this, on the right-hand side of the calculator is a button that says clear. Left of that is a button that says variables. I'm going to click on variables. Let me see if I can get this right first. When x is 3 divided by 3. Now the derivative. I got to see if I can think about the derivative. I can figure out how to insert. I'll go to math. Quit calculate. dy by dx right there, number 6. Quit. Okay, let me see if I go. It's another place. Where is it? Let me see if I can find this dy by dx. Hang on. Because I saw it there, but that's not the right one. Math. I think in derivative will work. Okay. Let's go number 8. Let's call in our function. Now I just got to remember the syntax. When x is 3, we want the first derivative. Let me see. With respect to x. I'm pretty sure this isn't right. Okay, what I'll do a quick search, because we still got a solid over 5 minutes. We'll just do a quick search on how to do the derivative on this guy so I can get the syntax right. And I think I'm gonna just do it here. We're just right there. We got it. To take the derivative, TI-83 plus. Okay. I just need one example right there. The function with respect to x, so where is that? Math until in derivative. So you have your function with respect to x when given the x value. Okay. So we got our function, because that's how I'm gonna have to call it. So then with respect to x, let me back up right here. So this needs to be x when x is 3. Okay, so I think when you're doing it like in a 83 plus, when you take the derivative, it has to be, you have to give it an x value, right? It's not like a TI-89, like if it was TI-89, it'll leave it as a function. This one, you can only do it at specific values. Okay, so we got like 15 and some change. Let's see if it worked. I think that we're just gonna find out here. 0135. 15, 0135. Let's see how do we do. Okay. So again, this will be the same as the answer that I have in the above line. I just plug in when x is 3. Instead of doing all those calculations where I probably made a mistake, I just did it, tried to take the original and let the calculator do the derivative when x was 3. And I got this result, and we're going to check on the next slide if this is correct or not. If it's not, then we're going to have to figure out where we got it wrong. We still got over 5 minutes. 15:01:35. Let me scroll to the end. Oh, okay. So let me see. Average profit. I think we're good. I think what we did was correct. We just made a miscalculation somewhere. Yeah, I think this is all good. Hang on. X is 3. Okay, so let me check here. Oh, you know what? That was my profit function. So if I want the average profit right here, I need to divide by x. So I'm going to insert, insert, divided by x, and that should be a comma. I think we forgot to convert it to the average profit function. I think that's what was throwing it off. So it should be 11 point something. Yeah, we got it. I was like, I knew we weren't too far off. So cool. We were able to figure out where we made a mistake, fortunately. Right. So again, in our equation editor, we put it in as a profit function, which was the revenue minus the cost. And then when we go to take the derivative, we needed to convert it to the average profit function. So we needed to divide by x. We took the derivative with respect to x when x was 3. So you can see that in that last little bit there on the screen. And we got the proper answer. I know that was a little intense, do the best you can with stuff like that. 11.1959. Okay. Let me make a copy. Let me include a copy of this screenshot of this, so you can like reference it. And I'll just try to keep I won't do the whole thing. I just want you to like, about like there is good. And so I'll leave this here as a reference if I can make it presentable. Let's get rid of this. We're going to close out. I know that's kind of small. Hopefully you can see that. It's just for reference. Okay. So now so we did it. What we did was correct, right? Let's recap what we did and then, try to do a little bit of a disclaimer. And the disclaimer is basically the main takeaway here was basically the shortcuts for derivative is what we explored today, right? So it got a little, these examples do get a little bit dicey. Again, you do the best you can. You take your time, slow things down, give yourself space, like plenty of clean paper. And the main takeaway from today was the power rule for derivatives, right? The power comes down and we subtract one. The sum and difference rule for derivatives, right? The derivative of a sum is the sum of the derivatives, so on and so on. We also talked about the product rule and the quotient rule. So power rule, sum rule, difference rule, product rule, quotient rule. Those are the main takeaways. This last one, don't stress about it. That was like a application of the quotient rule, and sometimes they get nasty like that, right? So just do the best you can with those. But if you can get the gist of power rule, sum and difference rule, and then product and quotient rules, that's the main takeaway from what we experienced today. Okay. And so with this last one, we did, cost function, revenue function, profit function. Profit is revenue minus cost. So then the average function, you take those functions and divide by X. So that was part A. And then when it says the rate at which the average profit is changing. So we're taking the average profit. If we want the rate of change, we're essentially looking at the derivative. So we took the average profit and we took the derivative of that guy. So then that forced us to do the quotient rule, the whole low D high minus high D low. Quotient rule can be a beast, right? So just buckle up, buttercup, get ready, right? That one, just do the best you can. But the others, just do the best you can with the quotient rule, but the others are manageable. They're reasonable. Quotient rule can get a little bit funky. Even some of the other ones can get funky as well, but just try to like celebrate the whatever wins and just do the best you can with the other things. Don't let the challenging stuff make you shut down, right? Just do the best you can with those. If it's not sinking in, just put a pin in it, save it for later when you're more fresh. Yeah, I think that was a summary of that last one. So we eventually found our way, we found our error, and we were good to go. Here's a typed version of what we just experienced. Okay. All right, gentlemen. I feel like there should be questions. Let me kind of open the floor real quick for any questions before we go our separate ways. Going once, going twice. Let me do one more quick recap. So today we finished 1.5 and 1.6. Take a break, get some rest, eat something, take a nap, and then when you wake up and you're fresh, tackle this stuff. It's a good idea to. Hopefully, you guys have already sought out tutors. If you're still gaining access to Pearson, again, there's an option for you to get 14 days of temporary access. You want to go ahead and make use of that so you don't get behind. On Wednesday, we're going to work on sections, the next two sections. So we did 1.5, 1.6, so 1.7 and 1.8 on Wednesday. So then, and that'll take us to the end of chapter 1. Next week, we're going to be working on the first 4 sections of chapter 2, right? So this week it's a good idea to try to go ahead and finish out chapter 1 as best you can, because next week we already go into chapter 2, okay? If there aren't any burning questions, we're going to go ahead and end the session here. I'm proud of you guys. You got this. You can do this. We're going to end the session here from one beautiful mind to another. Enjoy the rest of your evening, and we'll meet back on Wednesday for the final 2 sections of chapter 1. All right, guys.
Professor, I had a quick question before you end the class.
You good? Go ahead.
Where could I find the course link on my math lab?
You talking about the course?
Blackboard isn't working. I've been trying to find the link.
So you can't. The only way to access, because even if I give you the course ID, you have to get into the course through Blackboard. If Blackboard is down, you have to contact the Morehouse OIT. I can give you the course ID. It may or may not let you in with the course ID because it wants you to access it through Blackboard. Let me pull it up real quick. Hang on. Give me a moment. So you could try going directly to Pearson. Where is it? My course is spring. Okay. So if you wanted to, if Blackboard is down and you want to access it directly, so the course ID is Phifer. Let me see, 42,156. Right, you can try using this course ID to access it directly. It may or may not let you in. If it doesn't, then that means you have to access through Blackboard because I linked it in the Blackboard. So a lot of times it does that. You can try using this course ID and trying to get into it directly. Okay. Any other questions, gentlemen? Once, twice. All right, gentlemen. So good luck with everything. Hopefully you got a study buddy. Find a tutor. Make use of the Ask My Instructor. Right, you go into the homework, you get stuck, be frustrated for a little bit. Click on the Ask My Instructor, and I can do video responses, and we can work on it together anytime. All right, guys, take care. See you next time.
Hey, Professor, I have one question. So, did you end up see how the due dates were? Did you change that?
When I checked them, they looked accurate because today we worked on 1.5 and 1.6, so that means through sections 1.4, like 1.1, 1.2, 1.3, 1.4, were due at the start of class today. 1.5, 1.6, 1.7, 1.8 are due at the start of class on Monday, so a week from today. So it looked right when I checked it.
So we were supposed to take the quiz before today?
Yeah.
Okay.
Yeah, the quiz, but so the homework and quiz, those are like, it's not a heavyweight. It's not a heavy part of your grade. If you're late on it or you get a 10% doc, it's practically nothing. Like from your overall grade, the bulk of your grade comes from exams. So so you should still be able to access the quizzes. It might be a late penalty, but you should be able to access everything all the way until the end of the semester. With anything that's late is just a late penalty. Okay. If you can't access it, then that's when I need to be like, okay, let me make sure. Any other questions, gentlemen? Once. Let me see if I click on view. Oh, maybe I'm already in. Okay. Yeah, it looks like they're all still blue, so you can still access them. I can't talk anymore. 1.3. The quiz 1.3, 1.4. 1.4. Yeah, 1.4 was due today. That's right. And then 1.5 is due next week. Yeah. And so basically it's a weekly quiz, right? So the quiz is every week, based on that week's material. Again, if it's late, it's minimal points. Just you get unlimited attempts. You can still earn up to at least 90%. Some of them are even 95% late. If I get an opportunity, I might go through and for later assignments, I might change it from 10% to 5%. All right, gentlemen. Any other questions going once, going twice? All right. Good luck with everything, and I'm here for support if you need me. All right, guys. Take care.
Have a good one, Professor.
You as well. Where is this thing? I gotta get into my other class. Let's check the chat real quick. Okay, that's fine. Yeah, 1.6. I mean, it's not. You got like another week, so it's okay.